Let's prove the chain rule for derivatives. The chain rule goes like this. Let y equal f of u be a differentiable function of u, and u equal g of x, a differentiable function of x. Then the composition y equals f of g of x is also differentiable, and furthermore dy dx equals dy du times du dx. Or equivalently, the derivative of that composition is f prime of g of x times the inside derivative g prime of x. Here comes one proof. Let h of x equal the composition f of g of x. Now we need to show that for x equal to c, h prime of c indeed equals f prime of g of c times g prime of c. Well, there's an important consideration here about the behavior of g as x approaches c. There's a problem if there are values of x other than c where g of x equals g of c. So we're going to assume in this proof that g of x and g of c are always distinct for values of x other than c. In a moment, we'll prove the more general form of this chain rule. But given this particular supposition, we now have h prime of c, that's the derivative of the composition, equals by definition the limit as x approaches c of f of g of x minus f of g of c over x minus c. And we do one of those tricks where we introduce a new term, g of x minus g of c divided by g of x minus g of c. I think you see now why we can't have this equal to 0. And then flip-flop the denominators here. So the first term is f of g of x minus f of g of c divided by g of x minus g of c, and then we have the second term there. And it's the limit of that product. Well, that's the product of the limits. What's the limit of this first piece? That's nothing more than f prime of g of c. What's the limit of this second piece? Oh, that's g prime of c. And hence we've shown that the derivative of h of c is f prime of g of c times g prime of c.